I'm here to talk about Devoted Health's journey from cron to Apache Airflow. I'll be discussing the problems we faced with our previous data platform and how we solved them using Airflow. I think this journey is a fairly common one, especially for startups, and I hope you leave this talk with a blueprint to implement it at your own organization. So who am I? I'm a data engineer at Devoted Health. I joined about a year and a half ago, and previously I worked at DigitalOcean, Fitbit, and Carbonite. I've been in the data space for about 15 years and an Apache Airflow user for about 4 years. You can follow me at GitHub and Twitter at AJBosco. What is Devoted Health? Devoted Health is a Medicare Advantage insurer in the United States. Given that this is an international summit, I don't think I have enough time in this talk to explain how healthcare in the United States works, but I will say that our mission is to provide healthcare to all our members like we want for our own family. We were founded in 2018 and first enrolled members in 2019. So we're a relatively young company. In addition to insurance, we also offer a clinical services solution called Devoted Medical Group. And our entire organization runs on a homegrown Devoted Tech platform, which is a modern tech stack, which we believe is a differentiator from other insurers because it allows them to move really fast, and we own our stack all the way down to the lowest level. So when I joined the company in January 2019, this is what our data platform looked like. Our source data sits in RDS. We use cron to schedule data pipelines, and we were using S3 and Redshift to store data and Periscope for reporting. And this stack worked pretty well for us. We had a number of successes with it. The biggest one is that it worked. It did its job, and we were able to launch a new health plan. Additionally, some key business operations were using data pipelines from this platform, and it was powering all internal reporting across the whole organization. However, the platform had a number of issues. One main issue is that cron doesn't offer dependency management, so we had to hope dependent pipelines finished in the correct order. We also experienced undetected system downtime, where sometimes we wouldn't find out that a pipeline was not running until a stakeholder noticed. Not really a great situation. Additionally, we had no framework for our pipelines, so each one was its own unique snowflake, which made onboarding developers relatively difficult. And the platform also had developers developing on their local machine, which wasn't always the same as a production instance. Maybe a library would be different or resource would be different, which sometimes led to it works on my machine issues, which could be difficult to debug. And finally, we didn't have any way to guarantee data quality, which is not really the best way to build confidence in a data system. I'm sure our data scientists were writing great code, but we didn't really have a great way to be validating it. So 5 months later, this is what our data platform looked like, and it still mostly does today. As you might have guessed from the name of the talk, we swapped out cron for Airflow. We also migrated from Redshift to Snowflake. I won't be covering that here, but Carlo Goudreau gave a really great talk about that migration a couple weeks ago, and I think it's probably available online. Now I'll walk through each of the problems we were facing and how migrating to Airflow helped solve them. First, we had no dependency management in cron. At best, we were relying on daisy chaining jobs together, and sometimes we just had to hope that they finished in the right order. So the solution to that is probably an obvious one, but we deployed Airflow, which is built around DAGs and task dependencies, so it took care of that problem. But how do we deploy Airflow? So like I said, the Devoted Health Tech platform is very modern. It runs on Kubernetes, and our platform team had done a lot of work to make it really easy to deploy applications there. Things like Ingress and Vault integration were already all taken care of thanks to the work of that team. This combination made deploying Airflow on Kubernetes a no-brainer for us. On the right, I have a diagram of what our deployment looks like, and I'll talk about some of these components later, but you could kind of take a look at that. And we moved the Kubernetes executor on Kubernetes because it had the additional benefit of each one of the tasks running in its own pod. This offers a great deal of flexibility for resource allocation and also allows us to have Docker images for specific tasks. So if we have a data science workload that has a library that is relatively large, we don't want to put that on our base image, we could just put it for that one task and have it have its own image. To deploy Airflow to Kubernetes, we're using two tools, Helm and Terraform. Helm is sort of a package manager for Kubernetes, and it describes the resources we want to be deployed there. deployment services, persistent volumes, things like that. If you're familiar with Kubernetes, will be taken care of by Helm. We use an internal Helm chart, but I believe an official one is coming soon thanks to the work of the Astronomer team. So I would recommend you start with that rather than try to roll your own. And we use Terraform to deploy Airflow. This is a tool that's built around the concept of infrastructure as code. It'll compare what exists in reality to what you actually want to exist, and then create or destroy those resources if there's any differences found. And we use this to do things like create the RDS instance you see there, create the EFS volume that we use for DAG storage, and also to deploy the Helm chart itself to Kubernetes. These tools in combination allow us to create Airflow instances on demand with a simple Terraform apply command. So now we had Airflow running, but we have to get DAGs deployed to Airflow. To do this, like I said before, we're using EFS for DAG deployment. So we mount that volume to every Kubernetes pod so the DAGs are available. So the scheduler, the web server, and the task pods are all mounted on EFS. And then we have a Circle CI job. They'll push DAGs to EFS, and you can see it in the picture there. This happens every time our DAG directory is updated in GitHub. So several times per day, DAGs are pushed out, and it requires no manual intervention at all. Most of the time, the data engineering team, we're not even aware that DAGs are being updated unless there's an issue. So it's working pretty well, this setup for us. So now we had Airflow running, but we still had the possibility of undetected downtime. And we solved this, again, maybe obvious, by monitoring Airflow. And how do we monitor Airflow? Our first line of defense against downtime was to take advantage of some features of Kubernetes, liveness checks and health checks. So these are constantly checking Airflow to make sure that the services are in a good state. And if they're not, they'll restart the pods automatically. And sometimes unplugging something and plugging it back in is the easiest way to fix a problem. So these actually do prevent a good chunk of alerts we might otherwise see. So the monitors we have, the health checks are on the health endpoint, which is built into Airflow. It tells us if the web server is having issues. And then we also have a custom script that looks at the scheduler and will check to see if there are queued tasks with no running tasks and no recently completed tasks, in which case there's a problem and the service will restart. Additionally, we're using Datadog to monitor other key pieces of Airflow, which will alert us to things like, is Airflow running? Have any DAGs finished in the last 2 hours? Or are we seeing a CPU or memory spike? If any of these things happen, our on-call engineer gets an alert, and we can address these before they start to impact stakeholders. So now we know that Airflow is up, but we still face the problem of maybe silent failures happening within our DAGs. So we solved that using the Option-E and Slack hooks, which are available in the upstream project, and these will push alerts to our DAG owners. Each team that owns a DAG is responsible for resolving the failures, but now they know when it happened. So it's nothing silent, nothing that you discover from a stakeholder telling you your report wasn't updated. You're able to address it ahead of time. Additionally, our data engineering team is able to build these alerts into every DAG automatically, which I'll cover how we do that in a little bit. So now we know our Airflow is running, we know our DAGs are running, but we still have the challenge of onboarding new users. Pipelines at Devoted can be written by data engineers, data scientists, analysts, or other teams. And like I mentioned, each of our data pipelines in our own platform are unique depending on the developer who wrote them. Additionally, Airflow itself can have a steep learning curve for newcomers. So we address this with something we call the YAML DAG builder. We are not necessarily creative with our names. So this is an internal library that, as you might have guessed, takes a YAML file and builds a DAG. It's an abstraction on Airflow that allows developers to build DAGs without any knowledge of the Airflow primitives. And the example you see on the right, you can see that the developer just needs to write a DDL statement to create a table, and then a data transformation to populate that table, and they can use either SQL or Python, and no prior knowledge of Airflow is needed. The data scientist or developer can concentrate on the thing that they're doing without needing to worry about how hooks and operators and things like that work. This also has the added benefit of all of our DAGs having a similar structure, which means if someone switches teams or someone just needs to look at a problem, they can understand how the DAGs are structured. They'll still need to learn all the business logic of their new team, but the DAG itself is relatively similar to what they've probably already experienced. It also allows data engineering to bolt on new tooling under the hood to every DAG. Like I mentioned, built-in alerting is a feature for every DAG at Devoted, and this is how we do it. Under the hood, the on failure callback is automatically populated on every DAG that comes out of the YAML DAG builder. This tool has made it far easier to onboard new users, and I think has increased the adoption of Airflow in the organization. We have people who don't know Python writing DAGs, and people in other teams that aren't the data teams too. The next problem we faced was environment parity. In our previous platform, our developers work locally on one machine and then pushed to a different production server that sometimes wasn't the same. And like I said, this caused some issues that could be difficult to debug. And we solved this with a tool called Devflow, Airflow. We're not great at naming things. So Devflow is an internal tool that wraps the Kubernetes command line, Helm, and Terraform. You can see it there on the right with some fancy ASCII art that I put in to make it look a little more professional. It allows every developer at Devoted Health to spin up or down their own personal Airflow development instance on Kubernetes. This means that every developer is getting a exact replica of our production deployment and using the exact same stack. So this completely eliminates the problem of environmental parity. It also has the benefit of being able to take advantage of, like I said, we have Vault integration already built in the Kubernetes. People don't have to worry about secrets or anything like that. It's all taken care of. And developers are isolated from other developers. So if someone, on the off chance, writes something that causes issues in their instance, they don't bring down Airflow development for other developers. All DAG development is done at Devoted this way, and it requires no knowledge of the underlying infrastructure, Kubernetes, Helm, Terraform, nothing. All developers need to do is run a Devflow sync, Devflow start, commands like that. And I think it's become a pretty big hit amongst our data scientists. Like I said, all DAG development is done this way, so it seems to be working. But we're continuing to refine and improve the tool and kind of making it a one-stop shop for development. So you can see we also have some commands in there that allow people to clone tables in Snowflake, if you're familiar with that, or push images to ECR. So you could just use this one tool for all development. And so this kind of both solves the onboarding issue, it makes it easier for people to develop, and the environment parity issue. The next problem that we had with our data platform is we didn't have any tooling around data quality. It was up to each developer in our who was writing a pipeline to validate that they were producing good data. I'm sure most were, but it was up to them to put it in. So each pipeline was unique because of this. Some would have data quality checks, some wouldn't. So we solved this one the old-fashioned way with testing and validation. And the first thing we implemented is perhaps the easiest thing to test was unit tests for our Python transformations in our core libraries. Things like the YAML DAG builder, we wrote unit tests for them. And we use PyTest for that, and it runs in Circle CI for every PR deployment. And you can see a screenshot there of what our Circle CI tests look like for that. At this step, we also will lint the code and use black for formatting so that we have some consistency within our Python code and try to keep some coding standards up. We also implemented integration testing specifically for SQL. And this was more difficult to get working and is still a bit of a work in progress for us, but we think it's really valuable and important. And so we're using an internal framework right now, which is based on PyTest, and we'll create tables in Snowflake in a test database, load them with mock data, and then run some tests directly against Snowflake to see if the SQL is producing the output that we would expect. These will run anytime a DAG that has an integration test is updated. And again, they're executed via Circle CI. And this combination started to really give us confidence that the DAGs we were developing were doing what we expected and would not cause, hopefully, many errors or issues. Testing itself is going to help us catch DAGs before they were deployed, though, and we also wanted a safety net to prevent bad data from getting into reports in case one of these tests was passed for whatever reason and the DAG was still producing bad data. So for this, we developed a data validation framework. And these are tasks that are executed at the DAG runtime, and they can stop a DAG with data issues from being loaded into our reporting schema. So like the second there's a failure, it alerts and the DAG stops. And so we started with the standard check operator, which again is in the upstream project, and that worked really well. It executes a SQL statement, tells you if the value passed or not. We've recently started to add some additional features and create our own internal operators to make it a little easier to debug failures. Like for instance, we are now writing data to a permanent table if it fails or has invalid records. So the on-call engineer can come in and immediately see what happened and be able to resolve the issue faster. We've also started pushing check values to Datadog with the hopes of using its anomaly detection tools. So if we see that a value is always 1 and now it's 2,000, it might be greater than 0, so it passed the validation check, but that's an outlier. We want to be alerted to that and make sure that that's actually a reasonable thing. And the last thing we've added is the ability to run multiple data quality checks in a single task. So this means you don't have to wait for Airflow to spin up multiple pods if you want to run multiple checks on a single table. And this helps us with resource allocation and also makes the DAG performance a little better. Our data validation checks range from things like standard tasks that will check for if there are no duplicate records to custom business logic that might be specified by a single task. And you can see an example of each of those using our YAML DAG builder there on the right. The top one is one of our standard uniqueness checks. You just give it a primary key and it'll run and say, hey, there's no duplicates, or alert if there are. The second one down is an example of one of our custom logic. So a developer would write a SQL statement that could check whatever business logic they want, produce a pass value, and will alert. And the third one there is one of our examples of our new quality check tasks, and that runs multiple tasks. So there's a Python file that describes those tasks and will check the table for multiple quality issues. So mission accomplished. We solved all our problems at Devoted, and now data engineering is easy street. Not quite. We do have some future work planned, and some of the things I discussed are also we're planning on improving and exploring some of the new features that are coming in Airflow. As I mentioned, our SQL integration test is still a bit of work. They require a good deal of boilerplate and knowing PyTest. And like I said, some of the people who write pipelines don't know Python or aren't familiar with PyTest. So we'd like to remove those two dependencies. And I know some tools like dbt and Dataform offer SQL testing right out of the box. So we'll probably explore whether or not they could be something that we integrate into our platform. The second thing we'd like to do is improve the YAML DAG builder. Right now, each developer has to write that DDL statement every time and an insert statement. There's a lot of common patterns being used, so we think we could take advantage of Airflow's Jinja templating to make generating common workflows even easier and reduce some of the maybe error from copying and pasting or having to hand type the DDL. Another future goal, and this is maybe a big one for us, is we'd like to have SQL linting, formatting, like we do for our Python code. Like I said, we use Black for that. We've been exploring whether there's a good solution for Snowflake SQL, and we haven't found one, so there's been some discussion about building a tool internally. We think that this will be able to enforce programmatic best practices and things like that within our SQL, and we write a lot of SQL, so we think it'll be super useful. The last thing we're planning on working on is improving or experimenting with the new Keda autoscaler that Astronomer recently announced. And so one downside we found with the Kubernetes executor is that every task is a pod, which I also mentioned was a positive, but that means every task needs to spin up its own pod. And there can be some performance constraints on that because it takes a few minutes or seconds, depending on the image, to spin up that pod. And I believe that this new autoscaler resolves that. So we think that'll really reduce some of the downtime that the spin up time that we're experiencing. So that's probably something that we'll be working on in the next quarter or so. And that's how we migrated from Airflow to cron.
Can you guys hear me? Can someone from the audience confirm?
I can.
I think this is one of the problems Airflow should solve somehow.
Yeah, I saw one. where they did the S3 sync sidecar, and that was something that looked really interesting. We tried the Git sync approach, but it had some performance issues because we run a mono repo, so our Git repo is relatively huge.
So when you want to deploy new decks, do you just recreate and push your Docker images, or is there another way?
So it's everything's mounted on the EFS. There's nothing baked into the Docker image, so it's pushed to EFS, and the Docker images are relatively static unless we add a new library or upgrade something there.
Looks like the technology is awesome again. Everyone can hear me. Thank you for confirming, guys. Any more questions? Which Airflow 2.0 feature are you most excited for, Adam?
Which one?
Which Airflow 2.0 feature are you most excited for, if you have been following the mailing list?
I think we're excited for a lot of them. I mean, I know it's not an Airflow 2.0 feature, but like I said, the key to autoscaler is something we're really excited about. The functional API looks really useful. I think pretty much everything that's there is things we want to see. Performance improvements. Like we're really excited for 2.0. Like I saw it and I was like, I want this now.
Okay, so we have another question. Have you considered poor SQL for SQL formatting? If not, what have you tried so far?
So we do use the I think like the Poorman SQL formatter as like our VS Code plugin, so developers can format locally. It doesn't work perfectly with the Snowflake syntax, and we also create a lot of UDFs in Snowflake, so it doesn't understand like what one of our UDFs is. So it like gets you like 85% of the way there, and then you have to like hand format it. So that's why we don't have like a CI dependency on that to say like your SQL has to meet this standard. Yeah.
What version of Airflow are you running on?
So 110.10. We haven't upgraded yet, but I know the new version pushed out like 2 days ago, so it'll probably be this week, next week.
So I think the related question would be, how do you manage updates to a newer version?
Yeah. So like I said, with the Helm Terraform setup we have, we can spin up new instances pretty quickly. So we have always running staging instance, and we test first like with our independent development instance and make sure that it doesn't cause any problems. Then move to staging, try there, and then finally get to production. We also always have a plan to roll back, though sometimes with the database migrations, it could be a little tricky in Airflow, but we've done that before when we needed to.
Do you, in that case, do you manually execute some SQL statements to undo some changes?
Yes. Yeah.
Okay, so other question is, can you expand on how your scheduler health check script works?
Yeah. So it pulls the database, the Airflow metadatabase, and will check to see like whether there's queued tasks, like I said, or with no tasks running and no tasks recently run, like in the last 10 minutes, which would indicate that, hey, there's stuff queuing up, nothing running, and you should restart and see if that fixes it. I think there's in the astronomer Helm chart, there's like a really similar thing in there. So like I said, I think I would recommend checking out your code and using that before you try to maybe roll your own. But we didn't know that existed, or maybe it didn't exist when we first started. So
what is the number of decks you have deployed? Because I think you said if the scheduler is not processing any new task in 10 minutes, so just want to know the amount of load you have.
we have 55, maybe 60 DAGs. Not like we're not like one of those 2,000 DAG setups like Lyft or anything like that yet. But what it's doing is checking to see if in 10 minutes, like if a DAG is, if there's something that has been stuck in queued for a long time. It's not necessary that nothing's finished in the last 10 minutes.
Nice. And what was the oldest version of Airflow you were using? Like you were using it from 110.0 to 110.10, right? You have incrementally.
I mean, I have devoted. We started with whatever the latest version was when I got there.
Okay, yeah. So I'm going to repeat some of the questions because of the audio issues we had. First question was regarding, is this some love Airflow first of all, and is this something that you user that internal specifics of devoted health? Like, is it something specific to devoted health or something you want to contribute back?
I mean, the specifics would be around like the Terraform and Helm chart and things like that. I think we could generalize it. I never really gave it any thought, but if there, I think that would be something we'd be able to generalize enough.
And your setup is on AWS, so I would imagine your Terraform modules would be AWS specific.
Yeah. We'd have to generalize that piece, to do like other cloud providers. We're all AWS.
Adam already answered this one, but I'm going to ask this question again. One of the problems with Kubernetes deployments is that depending on the ways DAGs are shared with cluster, it might take some time to be picked up by the scheduler or workers. How do you solve it with Devflow to get locally changed DAGs to the Kubernetes cluster?
Yeah, like I said, we're using the copy command to move those out to the EFS instance. And for DAGs that already exist or in the DAG bag, it updates almost instantly. There is a lag for like a new DAG being pushed out. I think our data scientists and developers have just gotten used to it, but yeah, that is an issue for sure.
Are there any other ways you tried for DAG deployment, and why did you selected this compared to the others?
So we just used the EFS. Well, like I said, I guess we tried the git sync sidecar after we were already using EFS to see if that would be better, and ran into some issues because of the size of our monolithic Git repo. But using an S3 sidecar is something I'd like to explore. That was something I saw in one of the other talks that looked really awesome.
Thank you. Thank you for that. The other question, I think that so everyone heard that one. Have you considered poor SQL for SQL formatting? If not, what have you tried so far?
I think we already did that one.
Yeah. Why do you use Postgres?
Why do we use Postgres? Postgres is what we use for our production database, our devoted health tech platform. So that's what we, I think, had the most expertise on. So we use that for anywhere we need a relational database.
Awesome. I think we have time for one or two more questions. I think I'll ask one of them. I think you have used Airflow more than probably many of us. You have been using Airflow since last 4 years. How have you seen the project evolve over the years?
The projected improvement, is that what you said?
Yeah, the project and the community with it.
Yeah, I think, I mean, first of all, there's a lot more usage. The summit exists, so that's proof that the community has really grown. And then the project itself has just gotten better and better as I've been using it. I've previous deployments I had, like the first time I used it, it was kind of more like not necessarily a science experiment, but it might go down and I'd have issues. Now with the Kubernetes setup we have, I feel like there's a lot of confidence in what we're doing, and it just has gotten much more stable and I think closer to enterprise strength, which is really great to see. And a lot of the companies that are contributing back, Astronomer, Polidia, I think, I don't know how you say that, but that you see that happening, and I think that has been wonderful, and that's part of what's driving right Kubernetes Airflow 2.0, which looks awesome.
Awesome. Okay, so this is the last question we have. It's why did you select Kubernetes executor compared to Celery, or did you weigh the drawbacks, or was it something specific to devoted health?
We actually started with the Celery executor, and then we wanted the ability to have uh, more flexibility. We were using the Kubernetes pod operator with that, and then um, with some of our very specific images, we just wanted more flexibility in resource allocation and making it easier. So we migrated over. The Celery executor did work fairly well. I guess the downside there, right, is you have the static workers that are sitting there, which I think the key to kind of auto scaler gets rid of. So when nothing's happening on our Airflow cluster, it scales down to just two pods: the worker, the web server, and the scheduler. That's, I guess, is the biggest thing.
Would the KDA autoscaler change your mind to using Celery executor again with?
I think so. Like I said, it's on our roadmap to explore that. We haven't gotten a chance to yet, so I'm excited to see what's up with that.
Awesome. Thank you, Adam. I think I asked two more questions after I said that's the last question. So thank you very much for bearing with me, and thank you for your wonderful presentation.
Thanks.
Thank you guys for joining. See you in the third talk.